Hey guys, Mr. Martin with a quick video over nested for loops. So I've gone ahead and typed up a little bit of code so that we can get started. You don't have to watch me type a bunch of stuff to get going. All right, so nested for loop is if we have an outer for loop and then we have another internal loop that does something. So generally, nested loops are used to print grids of sorts. It's a way to type something that looks like a two-dimensional array. There are all kinds of reasons that you would do this. We won't even get into that, but we can like talk about how we can process what the computer is doing while we have a nested for loop. So if we have an outer loop, the outer loop is going to be the outermost for loop. So this one where we have I, if we start at I equals 0 and go up to 6, the difference between the initial value of I and the terminal value is how many rows that we're going to have. So since I starts at 0 and ends at 6, we expect to have 6 different rows. And then this internal loop, the difference between the initial value of J and the terminal value determines the number of columns. So it might be more helpful while you're first learning this to think about this as being row, or you can use R for row if you want. You know what? That'll be quicker to type most of the time. So we'll go back and say this is R initially, so row, and then internal we get column. And so then you can do all kinds of stuff. You can print like weird triangles and whatnot if you want to, but that's not something that we're going to do. So we're going to have row times column. So now initially what happens is you set R equal to 0. And then this internal loop processes each value of C. So right now we're telling this to do for R equals 0 to 6, then jump into this other loop where C equals 0 up to 5, then print R times C. So what we expect to happen first is we're going to have R equals 0, and we're going to take 0 and multiply it by each value of C. So that's going to be 0 times 0, 0 times 1, 0 times 2, 0 times 3, 0 times 4. And then since we get to 5 and it's going to stop, we're going to have 0, just a string of zeros, each separated by a space. We jump out of this inner loop, and then we print a blank line, and then we jump to R equals 1, and R is going to be 1. And so then we jump back into this other internal loop. And so we're going to have 1 times 1, 1 times 2, 1 times 3, 1 times 4, 1 times, and again, we're going to stop when we get to 5. And so then it's going to print each of those multiples of 1 up to 5, separated by a space, print a new line because this new line is inside the outermost loop. And so it's just going to continue to do that until we get to R equals 5. And so when R equals 5, we're going to jump back into this internal loop. We're going to have 5 times 0, 5 times 1, 5 times 2, 5 times 3, 5 times 4. So we expect this to have look a lot like a multiplication grid without the proper formatting where the numbers are lined up. So we're going to run this and see what we get. And so we do get what we expected. So here in this first row, R is equal to 0, and each of these values, so this is R equals 0. Well, we'll talk about this. So the first row is R equals 0, and then for this first column, C is 0, C is 1, C is 2, C is 3, and C is 4. And we see that in the second row where we have R would be 1, C is going to be 0, C is going to be 1, C is going to be 2, C is going to be 3, and C is going to be 4. And it keeps processing like this until we get down to R equals 5. And so then C is going to be 1, C is going to be 0, C will be 1, C will be 2, C will be 3, and C will be 4. So that's 5 times 0, 5 times 1, 5 times 2, 5 times 3, and 5 times 4. The way you will see questions like this from the College Board is they may have some other value. Like I initialize the value of count to be 0. So instead, what you will generally see is something like count plus plus. And we'll take out this print line. And so in this inner loop, we increment count for each value of C. So it's going to increment 0, 1, 2, 3, 4. It's going to increment 5 times, but it's going to do this for each value of R. So you come up with what you think count might be. I would say it's going to be 30 because this is going to run 5 times for each value of R. And since we have 6 values of R, that's just going to be 6 times 5. And we can check this all right, so we're outside of this loop. We'll just tab over. And we'll just print count at the end. And again, we expect count to be 30, and we'll see what we get. So count is going to be 30 because, again, what happens is R is initially going to be 0, and it's going to process count for each value of C. So it's going to increment C, it's going to increment count by 5 for R equals 0, and then it's going to jump to R equals 1, increment count 5 more times, and it's just going to keep doing this until we get to R equals 5. But remember, we started at 0. So this is really still having 6 values. And what's weird is that you could even have a loop inside of this loop. So say inside of this other loop, we type for int, we'll call this k equals 1. K is less than, we'll say 3, and we'll do k plus plus. And inside this loop, we want to put count, and we want to increment count by 1. So now what we expect to happen is, well, this is the inner k is going to process, is going to start at 1, go to 2. You know what? We'll make it less than or equal to 3. So k is going to start at 1, go to 2, go to 3, jump back out, and it's going to process 3 times for each value of C, which is going to process 5 times for each value of R. So if we wanted to know what count would be, we honestly can just multiply by how many times each loop is going to execute. So this inner loop is going to execute 3 times. This outer loop, the most inner loop is going to execute 3 times. The next inner loop is going to execute 5 times, and the outer loop is going to execute 6 times. So that's 6 times 5 times 3. We would expect count to be 90 then, because 6 times 5 times 3 is 90, and we'll see what we get. So count is going to be 90. So the only difference is we have to pay attention to like small things that could come up, where basically is when like when we don't start at 0, and we also have to pay attention to if there's equality or if there's not equality. Because if we make both of these less than or equal to, so now this outer loop is going to process 7 times, this is going to process 6 times, and this is going to process 3 times. So then that's 7 times 6 times 3, which is 42 times 3, which is 126. So we run this again, and we get count equals 126. So the last thing I want to show you is that you can print some, we won't say cool, but you can print some interesting things with a couple of nested loops. So say right now the value of C is independent of the value of R, but if we set this to be C is less than or equal to R, then we'll make it strictly less than R. So R is going to be 0. So when we jump in, you know what, we will make this one less than or equal to. So when R is 0, this is only going to execute for every value of C that's less than R. So 0 is less than or equal to 0. So we're going to we have to tell it to do something. So that's why, and we'll say print R. We'll say R plus C. So when R is 0 and C is 0, this loop is going to execute once, because only 0 is less than or equal to 0. So then we'd expect 0 to be printed the first time. Then when R equals 1, there are going to be 2 values of C, that are less than 1. C is going to be 0, and then C is going to be 1. And that's because we're telling it to increment by 1. So then in the second time, we're going to expect to have 0. So in the first time, we'd have 0. The second time this loop executes, we're going to have 0 and 1. And then when R jumps to 2, we're going to jump back into this inner loop. C is going to be 0, C is going to be 1, and C is going to be 2. So we're going to have 2 plus 0, 2 plus 1, and 2 plus 2. So we expect to have, well, we'll just run it and you'll see what we get. Oh, I put that print line. I wanted to print. We just want to print and we'll separate we'll just print and we'll take out, I will keep that print line. So we run this again and we get 0. That is not what I want either. I want, oh, I didn't put a print line statement outside of this, inside the inner loop. We want, I don't need to print count anymore. So what we're trying to do is just, it's going to print something like a triangle. And to do that, we need to print from the inner loop, and from the outer loop, we need to have a new line for each different row. So now when we run this, we'll get 0, 1, 2, 2, 3, 4, 3, 4, 5, 6, 4, 5, 6, 7, 8, and then 5, 6, 7, 8, 9, and 10. Because again, what's happening is you're taking the value of R and adding it to C. So when R is 0, that's going to be 0 plus 0 because that's the only time this executes. And then when R is 1, we're going to take all of the values of C that are less than or equal to R. And so we're going to have 0 plus 1, and we're going to have 1 plus 0 and 1 plus 1, which is 2. And so when we run this again, we get 1 and 2. And so then in this third line of the loop, when R is 2, there are 3 different values that are less than or equal to 2. That's 0, 1, and 2. So we're going to have 2 plus 0, which is 2, 2 plus 1, which is 3, and 2 plus 2, which is 4. Then when R is 3, we're going to have C is going to be 0, 1, 2, and 3. So then we're going to have 3 plus 0, 3 plus 1, 3 plus 2, and 3 plus 3, and so forth until we get up to R equals 5. And so then if we start at 0, they're going to be 6 values that are less than 5. We're going to have 5 plus 0, 5 plus 1, 5 plus 2, 5 plus 3, 5 plus 4, and 5 plus 5. And this is how we could print a triangle. There are all kinds of problems that deal with for loops that look like this. And a lot of those are found at codingbat.com, the site that we registered for the previous class. So I'll leave it to you guys to be clever and figure those things out. So that concludes this, I guess, somewhat lengthy video over nested loops. Remember, if we're printing, fixed values, the outer loop controls the number of rows, and the inner loop controls the number of columns. And if we're just incrementing a value based upon where the increment statement is inside the innermost loop, then that value is going to execute the number, just how many times each of the loops executes.